Hello guys, you're welcome back to my channel. In today's class we are going to be applying wind load to this structure. We also apply temperature load to this structure. If you have missed my previous classes, I urge you to go and watch them because we started the model of this structure from scratch to this stage. If you look at the loading aspect, we have already created the primary loads. Already we have done that. So the link is below. Just click on the link and watch the previous classes in order to be on the same page with us. If you are yet to subscribe, please click on that subscription button and click on the bell button for notification in case any day I upload video, will be one of those that will be notified. Yeah, okay. For the wind loading, you simply click on loading, but before we do that, let us get the total height of the structure because we are going to be needing it. We see the structure is itself is 11.6, and then we see the handrail height is 1.1 meters. Then I have my ladder projecting. Okay, let me just let me get the ladder from here to here is 2.7. so this plus that will give me the total height of the structure. Okay, I will do that immediately. 11.6 plus 2.736 give me 14.33. so we are going to be needing this. Okay, so we go to loading, click on the load cases detail. We have already applied the self weight, the grating load, the empty weight of empty tank. This is actually elevated water tank. We've already applied the weight of water on the grating beam, on the grillage beams. Sorry, we have already applied these ones. Life load on grating and life load on fixed ladder. So as I click on them, you see dead load is there. You see this one. You see the ones. This one is the empty weight of tank. On the grillage beam, the weight of water, and you see the grating. This grating is the direction is going is not global Y. I have to change it to global Y. If you look at the arrow is pointing towards another place. It's supposed to be global, not local. Yeah, exactly. Should be going downwards. All the load should be going downwards. Then this is the ladder life load. That's good. Like I said before, if you missed my previous classes, I actually have a long video where I modeled this structure, about an hour plus. It is very impactful video. You actually learn how to model from scratch, and the shortcut to even model, the easiest way to model. If you have missed this class, the link is below. Just click on that link, go through my previous videos and get this knowledge and be on the same page with us. So okay, now we quickly go to the business of the day. For the wind load, I'm going to be minimize these ones. Go to definitions, click on wind definition, click on add wind 1. You can write any name here. I'll choose codes. Here are codes available on Staadpro for now for wind load application. If you want the wind load to be calculated automatically and be applied to your structure automatically, these are codes you can use to do that. But in case you are using any code that is not here, you need to do it manually, calculate it manually. Maybe I will do that on a separate video for you to know how to do it manually and apply it manually on the structure. So now here we have a ASCE 7 1995. We have 2002, we have 2010, 2016. We have other codes. So I will choose this one, 2016. Now click add, close, click on it, click on add again. So we are going to generate this automatically. So okay, but I can click exposure. So for this one, I'll normally use 0.8 exposure. You can use one. I use 0.8 exposure. I'll close. Click here, add again. Then I will generate this. Generate. Then I will be filling all this according to what I have. So for now, I have a classification category. Let me go to my Excel sheet to get that immediately. We have classification is 2. My classification is 2. Classification is 2. I will leave it like that. Then basic wind speed. Basic wind speed. My basic wind speed is 40 meters per second. 40 meters per second. So I'm going to change the unit here to meter per second. Then this value to 40. Good. Then the exposure category. The exposure category is C. So I'm gonna change it here. Exposure category is C. Change the exposure category. Then structure type within structure, chimney, tank, and solid sign, open, lattice, trusses. Let me just leave it on building. Then height above sea level, so that's where that our calculation comes in. 14.336. I'll put it here. 14.336. Don't forget to change it to your unit. This is meters. That's good. We are good to go. Then I'll click OK. I'll click add. They have calculated the wind forces at various heights. Forces at various heights. If you scroll down, you see more. Yes, that's that. I'll click add. Good. Then this my exposure. I will assign it to view. Yes, good. Then I will now come back to my load definitions. I'm gonna add load cases for my wind load. We have to select wind load from here. We now type wind load in positive x direction. I'll copy this. See, add wind load in the opposite direction of x. Wind load in positive z direction. Add wind load, Ctrl V, wind load in the opposite direction of z, negative z direction. Click on add. Then come to x again and say add. Wind load, select wind load here for x, positive x phase. we have okay, before this we still need to get another dimension. If I click on, let me remove the first one, and then I'll add the total width this way, total width this way. Yes. Okay, this one is 1 meter. This one is 1.650. Have you? Yeah, that's good. Okay, then I can go back, say add wind load in positive x windward face. So for y range, minimum of 0 from 0 to that our height 14.336 14.336 for x range. This one is going to be from minus 1.6. I should check well. Okay, for x, minus 1. The 0 point is somewhere here, so it has to cover the offset of 1 meter behind it. That's the minus 1 I'm referring to. Then from there to this place, yeah, let me try something. So from here to here will now be my maximum. So minus 1 to 3.4. Then for z has to recess minus 1.65. This figure minus 1.65. So from here to here 4.05. 4.05. The structure is an open structure. Now click on add. Okay, let us check this one first before we continue. Okay, let me quickly off the load figures, so that load values, sorry, so that we see. Yeah, that's that. Okay, can as well increase the let's increase the scale. Go to labels, scale, distance force, let's take it to 0.5. apply. Yes, that's correct. So you can see the load you have applied. You can see the direction. This is positive direction of x. See, everywhere is covered to this height. That's the sense of putting in the total height 14.336 to cover every every height from the footing, from the support here to that point. So we quickly do others. Do for negative x wind load. Click on this negative x direction. Open structure from 0 to 14.336. I hope I'm correct. Yes. Then x remains -1 to 3.6. Oh, it's still 3.6 or 3.4. 3.4. For z, we have minus 1.65 to 4.05. 4.05 is an open structure. Here, this factor here, because I'm talking about the negative direction of x, I'll put minus before it. Without that minus, you are still doing the positive side. I'll add and close. Sorry. Okay, let's see. If we click on it, see the direction has changed now to the other side. That's good. We do the z direction, wind load, positive z is still 14.336. X range -1 3.4 minus 1.65 4.05. Open structure, positive z direction. We'll add that. Click on it. You see the direction is in positive direction. Don't forget our Cartesian coordinates. You see z, you see x. In the same way, it respects it. This direction is pointing towards z here. Okay, let's quickly do the negative direction of z. Add wind load negative z from 0 to 14.336 -1 3.4 minus 1.6 65 to 4.05. Don't forget to put the sign minus sign before this factor. It's an open structure. Add. It's now moving in the opposite direction. That's wonderful. Okay, So we now do temperature load under my primary load cases. Select temperature here, temperature load. Temperature load, call it TP. Add. Let's go to my Excel sheet. Our temperature load is 40 degrees Celsius. Okay, we come here, click on add, click on temperature load. Here we put 40 degrees. See add, close, select and assign to all, assign to view. Say okay. Temperature load assigned successfully. That's good. This is my temperature load. Yes, we are done with wind load and temperature load application. Yes, you can see very interesting and educative. So if you are still yet to subscribe, please hit the subscription button and like my video. If you enjoyed it, if you learned something like it, share. Please share with your friends, share with your classmates, share with your fellow engineers, and give me your comments. Let me know how you feel. Give me a comment. Let us interact. You can as well request for a video tutorial that you want me to prepare for you. Thank you very much for being here in this channel. Always come here, always be checking up on me through this channel to look out for new things I'm posting. I'll keep posting new things, solving people's problems, answering people's questions. That's the purpose for this channel. I appreciate you so far. Don't forget to subscribe, like, and share. Thank you very much. In our next class, we'll be doing load combination. It's going to be load combination. If you have not done load combination using American code, wait for that video. It's coming. Depending on when you are watching, maybe it has been dropped. You can still go and check my channel, browse through the videos. You will see anything you are looking for. In case you don't see, comment on any of my video and request for whatever you want me to do for you. Thank you very much and see you next time.